Good morning, all of you. Jai Hind to all. My name is Babita. I'm assistant professor in MCA department at Akgec Garg Engineering College, Ghaziabad. So today we have another lecture in the series of computer network. So today's topic is a switching, and let's get start this particular topic, how it work in the computer network. So upon the completion of this lecture, learners will able to learn what do you mean by the understanding the switching, and another the types of the switching techniques, and next one we will talk about the pros and cons of each type of switching, and after that we will talk about the some differences between the all kinds of and all types of switching techniques, right? And along with we are discussing also the application areas where we use the different kinds of switching. So let's get discuss one by one all kind of switching. So first of all, we understood the concept of what is a switching. So basically, before discussing this particular topic in depth, we understood the need of this particular topic. As we know that the network is a collection of interconnected devices together, and that makes the system, and this particular system is known as a network, right? So in a network, we have a more than one devices. As previous lecture, we will discussed about some kind of congestions and some kind of access control techniques in which we discussed about the CSMA and CSMA, CA and CD. So basically there is the problem of the congestion. Congestion is occur when we in a network more than one devices attempt the transmission through the same shared medium. Yeah, we can say the same communication channel. So basically what happened there, when more than one devices attempt the data transmission through the same channel, so they collide each other, and they reflect, they harm the transmission, and the possibility is that there may lose the data. So basically this is the problem, and this problem is overcome by applying and by means implementing another technique. So basically this is the case of the switching. Yeah, how we can say that this problem is resolved by using the technique of the switching. So basically switching is performed when we have more than one devices, and among these devices we are defined a dedicated link, and through the dedicated link we are transmitting the data. So basically if I'm taking the example of internet, as you know, the internet is a wide spread area. Yeah, we can say is a worldwide approach in which we have a lots of, yeah, we can say we have a huge amount of devices connected to each other. So basically if the sender and receiver wants to feel just a one-to-one communication, so basically what we do here, we are doing here to link by dedicated link between the sender and receiver. So this is the main approach which we are going to discuss in this lecture, right? So basically to resolve this problem, what is the problem? Problem is that sender and receiver wants to one-to-one communication with each other. They wants to feel just the whole network, and just whole bandwidth is available for them only, right? So basically fulfill to this approach, fulfill this particular requirement of the sender and receiver, we are using some kind of topologies. We can say the mesh topology and star topology, because as you know, in the mesh topology you have a more than one devices, like this is the approach of the star topology, and this is the approach of mesh topology. So in which all devices connected to another device into the in a one-to-one approach, right? So So basically what happened is here, this particular implementation becomes more costly and inconvenient for the large number of systems, right? So it is a limited to small distance, yeah, we can say the small network types. So question is that how to resolve this problem. So basically this problem is resolved by the use of switching. So a switched network consists of a series of interlined devices called the switches, and it is a device which can create a temporary connection between the more than one systems linked to the switch. So suppose we have a more than one devices. Here we have a device 1, device 2, device 3, device 4 and device 5, and each device wants to connect with another device into one-to-one manner. So basically what we are doing here, we are doing we are using some kind of devices that's called as a intermediate devices, and this particular divide provide the connection between the more than one devices, because the one-to-one connection is possible only this particular devices, between these particular devices. Then how can we connect these devices also with each other? So basically we are using an intermediate device, yeah, we can say we are using an intermediate node, and this node have the more than one connections, yeah, we can say have the more than one channels to connect more than one devices. So this is the particular approach we will implement in the concept of switching, right? So this particular question is fulfilled by using this technique. So basically here we have a more than one types in which we are implementing the switching. So let's figure out how many types of switching. Here we have a three broadly classified into the into the three category, that is the circuit switching, packet switching and message switching. So basically the packet switching is further divided into the datagram switching and virtual switching. So let's discuss in depth one by one to each, right? Yes, before discussing, let's understand this figure and its implementation. As previously I already told about you, we have a more than one devices like this one, A, B, C, D. So basically here we have a more than one devices, and these devices makes a network, because all these devices connected to each other. So basically when we have a more than one device and connected to each other, so makes the form of network. But what is the facility or what is the actual implementation of switching? Because if the device A wants to connect device F, then how can it connect? It connect directly by this particular dedicated link, but this is not applicable because all the other devices remain unconnected to this particular network. So what what we'll do here, we are using some another kind of devices. These devices called as a intermediate node and switches, yeah, you can say some routers, and this routers and these devices have a multiple connections to make connected another devices. So this is the concept, right? So first type of the switching is a circuit switching. So basically circuit switching, if I'm giving an example, if you feel when we have not the facility of internet and packet switching, so basically this time at that time we are using the concept of circuit switching. If I'm talking about your very familiar concept, your telephone connections, right? So the telephone connection is just like your circuit switching, in which we have make the particular dedicated link between the sender and receiver. Just to suppose before 10 years ago you make call from your landline number. So what happened there, user just to dial the number and connections may connected, because your call, your message firstly delivered to the exchange center, and the exchange centers recognize your receiver address, and then they connect and they activate the particular path. That's why you connected to the dedicated, yeah, you can say intended receiver through which you are communicate, right? So circuit switching network is made up of a set of switches. Switches we can say, because if a sender is here at this particular location and receiver is here at this particular location, and this location just for example in a Delhi, and this location is just for example in Mumbai. So basically this is the reason and this is another reason. So between and if I am talking we are talking about a dedicated link. So basically this is not possible through the single link. या we can say हम ये कह रहे हैं कि A से एक वायर जाएगा और B तक जाकर के कनेक्ट हो जाएगा, तो it is not possible. It is a very complicated process. So basically we are connecting node by node. Just for example, through the Delhi, there is a head office just for example in Delhi, and another head office just for example intermediate locations, and from there the another link is go for your dedicated location. So basically what I'm saying here, मैं ये कहना चाह रही हूँ कि जब A से B का कनेक्शन हम यहाँ पे मेंटेन करेंगे, या we are approaching the dedicated connection between the A to B. So basically we are using some intermediated locations, yeah, you can say some intermediate head offices through which we are connecting with each other, right? So basically this is the concept of circuit switching. So circuit switching, in the circuit switching, once a connection is established, because when you are dialing your number, that means your connection is going to establish, and after the connection is established you are able to communicate with your intended receiver, and after that if you communicate, your communication is finished, then you terminate your connection. Yeah, you can say simply you disconnect your phone, right? So in a circuit switching, once a connection is established, then the dedicated path will remain to exist until the connection is terminated. This is the approach. So this particular approach we will understood by taking an example. So in this example we understood these three steps. First is your connection established, second one is your data transfer, and third one is your connection releasing, yeah, relinquishing, right? So basically here we have some devices like device A, device B. So basically this device is known as a sender and this is a receiver, and we want to share something and we want to send some data through A to M, right? So what happened, this particular device is known as an intermediate device, yeah, we can say as a switches, and these switches, yeah, we can say each node is divided into multiple channels. These are the some channels you can say, these are some multiple connections through which we can connect some other devices also with the same device, right? So basically if I am sending the data through A to M, so basically we maintain a connection. This connection is maintained in just like this form, right? So this is the dedicated link. Among the all channels, we have the other options and we have other alternative channels through which we can transfer the data from A to M. But I decided to take this particular path and this particular channel. So it is the dedicated link between A and M. So this is the concept of circuit switching. So in first we have to maintain, we have to make a connection. This connection also called as a call setup, and this phase established a dedicated link, right? Next, the party send a message back and forth acknowledging the established connections, right? So there is a that means when a connection is already set up, when a connection is established, then user can communicate with each other, and they communicate, the obvious है कि they receive some message and they send some message. This is called as a back and forth, right? And after that, there are usually intermediate links or switches between two parties, because these switches facilitate to the communicators to maintain the frequency of the network, right? And after that, data transfer. Usually, if I am saying this particular kind of approach is implementing only to transfer the voice message, voice type of information from source to destination. The connection remains intact for the length of the interaction. That means still you are communicating with each other, your connection maintained in the same manner, right? And after that, when you finish your communication and your message has been delivered, that the need of to releasing your connection, because if you are not releasing, then this particular dedicated link is not provided to other users. So it is a requirement. If your communication is done and your communication is finished, then you are releasing the dedicated, you are releasing the particular connection. This is called the tear down phase, and this is also called the termination phase, right? At the end of the interaction, one of the two endpoints sends a message initiating a disconnection. That means if your message is done, your transmission is done, then you are initiating the disconnection of the channel, right? And the communication path, including the intermediate links, also terminated. This is the process of circuit switching. Next, it has some advantages and disadvantages, because it facilitates the communication, and you can say when we have the problem of congestion, it facilitates some efficiency in the communication. So basically, circuit switching communication is dedicated because one-to-one connection is established here, and it has a reliability as obvious. If you have a dedicated link, that means you are reliable to each other, and your message definitely reach at your destination. And quality of service, if you have a dedicated link, then it is obvious your message accuracy is 100%, and when your accuracy is 100%, that means your services have the best quality. And ease of management, ease of management, that means we can say here your connection is a dedicated, and you can say in a single approach, one-to-one approach is going here. That's why we can easily manage this particular connection, right? We already know the path of the between the sender and receiver. And here we have a sub cons. We can say the disadvantage of the circuit switching. Just for example, once the dedicated path is established, the only delay occurs in the speed of the transmission. It takes the too long time, because first we have to make the connection, then we can transfer the data, then we have to disconnect the connection. So it takes some time, and we can say it make long time. This is a long time process, and it is more expensive than the other type of the switching, and it is efficient to use once the path is established and no data can transfer between the other devices. And so basically the capacity of the path is dedicated to only the connected devices only, right? And in the case of the connection is dedicated, there are no other data can be transferred if channel is idle. We can say if channel is free, we can say the dedicated device not interesting to transmit the data, that means network is remains idle, and but there is no facility to transfer with other devices, right? So these are some pros and cons of circuit switching. Next we will talk about the message switching. So basically the next technique always occurs when we in the previous technique we have some drawbacks, right? So message switching is introduced to overcome the problem of the circuit switching. So basically we can say it is the alternative to circuit switching before packet switching was introduced. So basically if I am talking about the best switching technique is the packet switching, but intermediate in the intermediate approach we also apply the message switching approach, right? So basically message switching transmission, in this transmission the entire message is sent as a single unit through the interconnecting nodes using stored and forward technique. Basically what happened is in this technique we have a combined message, yeah, we can say this is a message and this message is considered as a single unit, and this unit is transmit through the network, and this particular message as obvious message 1 message 2, but considered as a complete unit, yeah, we can say considered as a single unit, as we understood this particular concept by taking the example. So in this approach what happen is here, this is a sender and this sender sends a message, and this message is just considered as a message 1 and message 2, but these are some intermediate nodes, and what happens when this message arrives at that particular node, this particular node firstly store this message whenever it comes at this particular location, and after that is forward to the next hop, yeah, we can say to the next node. The condition is that your message should be complete at this particular position, and if your message completely received by this node, then this node search, yeah, we check the next interested node and links, obviously these particular node check out the link and the next node. If find out the link and the next node, then it forward the message. So basically this is the concept. So message switching is done into the two approach, stored and forward. What is the meaning of stored and forward? The intermediate node have the responsibility to transmit the entire message to the next node. Hence each node must have the storage capacity. This is the means another condition in the message switching, because if node have not the capacity to store the data, it cannot capable and they may chance the loss of data. So basically each node must have a storage capacity, and a message will only be delivered the next node, or we can say next hop and link connected are both available. If one of them are not available, then node will not transfer the will not forward the message to the next node. So basically a stored and forward switch forward a message only if sufficient resources available and the next hop is accepting data. So this is the stored and forward property. Next we will talk about the message delivery. So this is the concept. Next we will talk about the some pros and cons of the message switching. So basically in the message switching there are some shared among the communication device that improve the efficiency of using the bandwidths, because we are using the whole bandwidths of the network. Traffic congestion can be reduced by the message is temporarily stored in the node. So basically this is also the facility provided by the message switching. The size of message which is sent over the network can be varied. This is not necessary always the message size is fixed, because here the message size may vary time to time. And here we have some disadvantages. Message switch must equipped with the sufficient storage to enable the stored and forward property, and the long delay can occur due to some storing and forwarding facility, because it take time to store and forward. That means you may realize some delay in the transmission and not suited for streaming media and real-time application. Just for example, you are transferring some real-time information, so basically the delay is not acceptable in this situation. Next, we will talk about the packet switching. So basically packet switching is the best technique of this switching, and it is applies, yeah, we can say it is implementing in the internet. So what happened, packet switching is a switching technique in which the message is sent in a one go, but it divided into the some smaller parts, and these parts is known as a packets, yeah, you can say some datagrams. So packets are given a unique number, because if you are dividing your message into the some different pieces, and these pieces travel on the network by taking some different route, and how can you resemble these particular packets in a correct order? So basically what happened, we are assigning some sequence number through which we rearrange in the proper order at the destination, at the receiver side. So packet given a unique number, and these number identify the order of the packets at the receiver side. Every packet contain the information of its header, and this header is contain the address of the source and destination. Basically, if I am talking about the packet, it is implementing in the network layer, yeah, we can say on the internet, and on internet each packet have a particular header, and this header contain the information about the sender and receiver. If any packeting missing or corrupted, the message will send to the receiver, resend the message to the receiver, because if packet is lost, then definitely we will resend that particular message. So basically packet switching is also known as the connectionless switching. It works in a two different approaches. One approach is just implies for the connection oriented, and another approach is implies for a connection less. So basically this is the concept of the packet switching. Here we have a information, and this information is divided into some smaller packets, and these smaller packets may travel at a different route, or may take a different route to travel on the network. Just to suppose the packet 1 is take this particular route, and packet 2 is take this particular route, and may arise at a different order at the receiver side. But how can we rearrange? By rearranging these packets by using sequence number. So this is the approach. Next, if I'm talking about the different approach of the packet switching, is a datagram packet switching. So basically in the packet switching, the packet is known as a datagram, and these datagram may travel by using connection less approach. That means your packet not necessary to take a dedicated path between the sender and receiver. There is the datagram is freely take any particular route to reach the destination point, right? So each packet contain the information about the destination, and switch uses this information to forward the packet to the correct destination point, right? And after the reaching at the destination, the packet are reassembled at the receiver side in a correct order to understand the exact message or exact meaning of your information. So basically intermediate nodes take the routing decision to forward the packet. Here we have a intermediate node, and these nodes are capable to take the decision to forward the message to the next node. So basically datagram packet switching is also called as a connectionless switching. Next, we will talk about the virtual circuit switching. This is implies by its meaning, by its name as a virtual. Virtual, that means just an imaginary path. Yeah, we can say here is not a dedicated, but as we considered as a virtual path between the sender and receiver. So that's why it is called as a virtual circuit switching. The virtual circuit switching is also known as a connection oriented. It is not the connection, it is not a dedicated, but it just relies you feel just a dedicated path between the sender and receiver. This is the property of the virtuality. And a pre-planned route is established before the message is sent. So basically in this figure we have a more than one path to destination, to reach at your destination, but we will take only this path only. So what is this? This is a virtual path between the sender and receiver, and we will take it as a virtually. Whenever your transmission is finished, this particular path is disabled, right? So this is the virtual circuit. In it we take we can use some request and response. So call request is using to send the data, and call accept is using for receiving the data, right? In this case path is fixed before the duration of the logical connection. Till whenever we alive this particular link, you can transmit, you can use this particular path for your transmission. So basically these are the kinds of switching, and here we have a tabular a difference tabular in which we are showing the difference between the packet switching and circuit switching. So basically packet switching, in which your message is divided into the some smaller part, and this is called the packets. But in this case of switching, circuit switching, there is no there is a dedicated path between the sender and receiver, and no need to divide your information. So packet switching and data is processed at the all intermediate nodes, including the source system. But in a circuit switching, data is processed at the source system only, right? And in the next point we will compare these particular kinds of switching between the delay and the unit. Data unit in a packet switching is not uniform, but in the circuit switching, in the case of circuit switching, delay between the units are uniform, right? And packet switching is a less reliable because there is a no dedicated connection between the sender and receiver. That's why your message may take any route or any particular link to transmit. And but in the case of circuit switching, you have a dedicated link between the sender and receiver. That's why you have ensure your message definitely receive at your destination. So in a packet switching, less wastage of resources, but in the case of circuit switching, you are wasting some resources, because if your dedicated link is alive for the devices, and these devices not transmitting any data, that's why they are unutilization of that particular resources, right? It will setup is not required in a packet switching. As we see in a circuit switching, we have perform 3 major steps to make the connection between the sender and receiver before sending the data. But in the case of packet switching, there is no need to set up yet, there is no need to connect make the connection between the sender and receiver. Latency is high in packet switching. What is the latency? Latency is the difference between the transmission, we can say your submission and your receiving point. So in a circuit switching, latency is low. So basically these are some differentiation between the packet switching and circuit switching. That's all about this particular lecture, and this lecture is benefits for the MCA students and BCA, and as well as some UGC NET preparing aspirants. So basically this is more beneficial. Thank you so much.